In this video, we will see how to create a program with a loop and an alternative in AlgoTouch. On the AlgoTouch workspace, we have defined two variables p and q which contain the values 125 and 75 respectively. The greatest common divisor, GCD, of 125 and 75 is 25. Indeed, 25 divides both 125 and 75. There is no integer greater than 25 that divides both 125 and 25. An algorithmic method for calculating the GCD consists of subtracting the smallest integer from the largest and repeating the calculation until the two numbers are equal. But let's run an example by hand. You need to subtract 75 from 125. The result, 50, is kept in the variable containing the largest value, p in our case. As there is no equality, we must repeat the operation. Take a subtraction, subtract 50, 75, and store the result 25 in q, which contains the greatest value. Equality is still not achieved. We start again. Subtract 25 from 50 and store the result in p, which contains the greater of the two values. Equality is reached. The GCD of 125 and 75 is found. It is 25. We will now program this algorithm. But first we reset p to 125 and q to 75. The idea is to start with the general case, the loop body that we select in the code. We also put AlgoTouch in recording mode. We must compare p and q with a comparator. Among the three true choices proposed by AlgoTouch, we choose p greater than q. AlgoTouch asks us to specify the calculation to be performed in this case. It is the subtraction of q, which is worth 75, to p, which is worth 125. The result 50 is preserved in p. We don't have to do anything more. The case is over. Let's notice the code added by AlgoTouch. If p greater q, p equals p minus q, else. P less equal q comment to do the else is empty. It is specified that it remains to be addressed by a to-do comment. At the moment we have nothing to add to the loop body. We can stop recording to run the body in build mode. We select loop body and click on the green triangle. AlgoTouch tells us that the case p less equal q is not processed and asks us to complete the code. In this case, we must subtract p from q and keep the result 25 in q. This is the only calculation to be performed in this case. We can indicate this to AlgoTouch by closing the dialog box. The code was completed with else q equals q minus p. AlgoTouch takes control and completes the execution of the loop body. We could also have added the subtraction directly by selecting the else line in the code and putting AlgoTouch into record mode. We still haven't found the GCD, so we continue executing the loop body. Now p and q are equal. The GCD is found. We must add an output condition. Select exit conditions, put AlgoTouch in recording mode. A comparator appears. We compare p and q and choose p equals q. The exit condition is added to the code. The continuation condition p not equal q is added to the while of the Python code. There remains the initialization. Select initialization. Enter the value of p and that of q. To complete the code, we display the value of the pGCD, that of p or q in the termination. The code is complete and we stop recording. We can test the program by clicking on the macro triangle, for example, with 1025 and 125. The result is 25. Python, C, C++, and Java code is available in the console tabs. It can be used in traditional programming environments. In a future video, we will see how to create loop nestings with AlgoTouch.